Assalamu alaikum guys, welcome back. Okay, so now we are gonna study X-ray diffraction. This is the second last topic of this chapter. Diffraction is what you guys already know. By definition, diffraction means bending of a wave into geometrical shapes or geometrical shadow when it passes through a very small or narrow opening. Right, small narrow opening means that when it passes through a slit which is comparable to the size of the wavelength of the wave. X-rays are of the order of 10 raised to the power of minus 10 meter. This is the order of X-rays, right? They are in the order of 10 raised to the power of minus 10 meters. So for diffraction, slit size must be comparable to the wavelength of the X-rays. We must take slits that must be as small, they must be so small that they must be somewhere of this order, right? So suitable slits that we use are the slits in between atoms, okay, atoms of crystals, the spaces in between atom crystals, or the layers of crystals, layers of atoms in crystals, in uniform crystals, act as slits. So crystals of rock salt, basically sodium chloride, actually when you take sodium chloride, the common salt, the table salt, sodium and chloride atoms are arranged uniformly, right? If you look at this structure diagram over here, these dots represent sodium and chlorides arranged adjacent to one another, and the distance in between, okay, this entire line that I have drawn, the three lines that I have drawn over here, these are actually the entire planes of atoms present in sodium chloride crystals. Now the distance in between these two crystals, this is the interatomic distance, and this interatomic distance, or this distance in between the two layers of the uniform crystals, this acts as the slit, and this is of approximately 2.5 degree Armstrong. What is degree Armstrong? Okay, this A represents Armstrong. Okay, so degree Armstrong is equal to 10 raised to the power of minus 10. Okay, so ये basically is also, ये भी एक प्रीफिक्स की तरह हम यूज़ कर सकते हैं इसे भी, ठीक है, जैसे नैनोमीटर, पिकोमीटर वगैरह अब तक यूज़ करते हुए आ रहे हैं, तो डिग्री आर्मस्ट्रॉन्ग भी एक प्रीफिक्स ही है, ठीक है, एंड इसकी वैल्यू होती है 10 raised to the power of minus 10. अब ये 2.5 10 raised to the power of minus 10 is the distance in between adjacent layers of sodium chloride or rock salt crystals. This is actually smaller than the wavelength of the wave, 10 raised to the power of minus 10. Since the slit size is in that order and is smaller than the wavelength, is just slightly smaller than the wavelength, therefore diffraction is possible when the X-rays are incident upon these atoms. So the space in between them, space in between the atoms, it acts as the slit. So now let's look at the mechanism behind it, what's happening over here. So basically, for these red lines are representing X-rays. First focus on this one. This X-ray is coming and hitting the atom over here and hitting it on the top surface, and after hitting it on the top surface it gets reflected by an angle theta with the plane. The angle of incident and angle of reflection are equal to one another, so these two angles are also equal to one another, right? And by the way, this angle and this angle are also equal to those angles because these lines are parallel to one another. Now this second wave that I have drawn, it comes down, but instead of hitting the first layer of atoms, instead of hitting the first atom, actually it crosses the first layer and hits the atom in the right adjacent layer, meaning in the next layer, the second layer that we have over here. In this layer, the atom which is right adjacent to that first atom, this X-ray comes and hit that atom and gets reflected from here. When this X-ray comes and hits this atom, the distance that it has traveled is not the same as the distance traveled by the first ray, but rather this distance traveled by the second ray is longer than the distance traveled by the first ray. अब ये डिस्टेंस अगर लॉन्गर है, इसका मतलब ये हुआ कि सेकंड रे ने जो डिस्टेंस कवर किया है वो उससे ज़्यादा होगा, मतलब इसका पाथ डिफरेंस इन दोनों में एग्जिस्ट करेगा, राइट. एंड द पाथ डिफरेंस in case of X-ray diffraction can be calculated. Okay, now let's assume that this is the point till which the two rays have the same length, okay, and beyond this point the second ray has the extra length. Same goes for here. This is the point beyond which the two rays have the same length, but this is the extra length. These two lengths, their values are d sin theta and d sin theta. Okay, now how did the d sin theta and d sin theta come? You don't need to know, okay, because you are preparing for MD-CAT, and in case of MD-CAT you don't need to know the derivation. So path difference is actually d sin of theta plus d sin of theta. So this becomes, this part that is extra and this part which is extra are both equal to d sin of theta, and this one is also equal to d sin of theta. So the total path difference is gonna be 2 times d sin of theta, whereas d represents the distance between the two layers. Okay, the distance in between the two layers where the reflection and the incidence is occurring. This path difference can equal m lambda for constructive interference. For constructive interference, meaning for observing maxima, the path difference should be of the order m times lambda, right, where m would be any integer, 0, 1, 2, 3 and so on, right. So this formula that we have gotten over here, this is known as Bragg's law. This is important. Examiner has asked us to identify the Bragg's law, and the answer was this equation itself, where lambda represents the wavelength of this incident wave, d represents the distance in between the layers of the atoms, theta represents this angle over here between the incident ray and the plane, and m represents the order of the maximum which you want to calculate, first order, second order, third order and so on. This was all about Bragg's law and X-ray diffraction. Now what you guys need to learn is just this formula from here, and even if the examiner does give you questions, the questions are generally very easy. The data is already given to you, you just need to calculate it. And by the way, this value is also important. The distance in between the layers, it's 2.5 degree Armstrong, and this value is also important for calculations of the wavelength of X-rays. Actually wording वाले MCQs यहाँ से आ जाते हैं, ठीक है. This was all about X-ray diffraction. Thank you.